Okay, adding and subtracting surds. For the most part, it's extremely similar to addition and subtraction of algebra. So, if you have two surds, 5 times square root of 11 plus 7 square root of 11, they are what we call like surds. And just like in algebra where you only add like terms, in surds you only add like surds. So 5 times square root of 11 plus 7 square root of 11, we just end up with 12 square root of 11. Similarly, 8 square root of 5 minus 3 square root of 5, and we end up with 8 minus 3, 5 square root of 5. And just like in algebra, the terms that are not the same, you can't do anything to them. The surds that are different, you can't really do anything to them either. So minus 4 times square root of 2 plus 5 square root of 6. As you can see, 3 square root of 6 and 5 square root of 6 are like surds. You can do something to them. You can add them. So 3 plus 5, 8. However, this term here, 4 square root of 2, it's not the same. So you can't actually do anything to it, which means you will have to leave it to the side. And this is the furthest you can go. Of course, sometimes the surds will have to be simplified first before operations can be performed. So, for example, if we have 80 square root of 80 plus square root of 20, as you can see here, they are not like surds and you can't just add them. However, if you recall, x times y, square root of x times y is the same as square root of x times square root of y. So in this case, what we can do is that we can extract square numbers from these surds and we can do things to them. So 80 is in fact 16 times 5. And 20 is 4 times 5. And if we follow this rule here, plus, as you can see, both 16 and 4 are square numbers. So we end up 4 plus 2 square root of 5, and we end up with 6 square root of 5. So what happened is that we broke the numbers down into a square number and a number that will not, a square number, a non-square number. The non-square number will give us our surd, and the square number can actually be simplified into a whole number. And let's try another example where we have square root of 8 minus 27 plus 18. Once again, there's in fact a square number in each one of these. So we have square root of 8 is in fact 4 times 2. 27 is 9 times 3. And 18 is 9 times 2. So we end up with square root of 4 square root of 2 minus square root of 9 times square root of 3 plus square root of 9 times square root of 2. So 2 square root of 2 minus 3 square root of 3 plus 3 square root of 2. As you can see here, once again we have two like surds and we can just add them. 2 square root of 2, add 3 square root of 2, give us 5 square root of 2, and minus 3 square root of 3. As you can see, these two are not like surds, and therefore we can't do anything further to them. Last example, 5 times square root of 20 minus 3 square root of 125. In this case, once again, we can just break down whatever is under the radical sign into a square number and a non-square number. So we end up with 5 times 4 times 5 minus 3 times 25 times 5. So we end up with 5 square root of 4 times square root of 5 minus 3 times square root of 25 times square root of 5. And we end up with 5 times 2 times square root of 5 minus 3 times 5, correction, 5 times square root of 5. So we end up with 10 square root of 5 minus 15 square root of 5, and we end up with minus 5 square root of 5.